can't remember who this was. Was it Copernicus? Who knows? I'm not good with the science history. I really should be. But he was the one that figured out that when you sat in a bathtub, the water level of the bathtub actually goes up, right? And he yelled out the word "Eureka" when that happened. I wonder if that's like an urban legend or if that really happened. I have no idea. Anyway, so why is that even helpful? Why is that useful? Well, it's helpful and useful because you can use that principle to determine the volume of objects that are weird, weird shaped objects, right? If you had a block or something like that, it'd be easy to measure all three sides of that block and figure out what its volume is. But what if it's like a weird piece of metal or something that's very irregular shaped? Well, what you can do is actually put that object, like for example this piece of zinc right here, right, into a graduated cylinder, right, where you already have a known volume. Here the volume that you know is 35.5, 35.5 milliliters, right? But then you add in the zinc into the graduated cylinder and it actually displaces the water to 45 mils. So all you really have to do then is to figure out what the volume of that zinc actually is figure out what the change is, right? So that's 45 minus 35.5. Simple math there, right? Very simple math there. That's 9.5 mils. Right? That's 9.5 mils. So that's great. Now we know what the volume of it is. Then you can figure out what the density is of that zinc bar, right, by doing the equation that we learned in the last slide, which is D equals M over V, right? M over V. So how do we get the mass? It's already in the picture right there. You use a balance or a scale, right? And so when you do D equals M over V, that equals then the mass, which is 68.60 divided by the volume that we got from our volume displacement experiment, Eureka, which is 9.5 mils. Sorry, I forgot my units up there, grams. Don't ever forget your units, right? And you do that simple arithmetic there, and your answer is 7.221, right? And that's its density. Except, remember, always remember your significant figures. What is the lowest number of significant figures we have? Well, up here, we've got a pretty good balance, so it has 4 significant figures. But we only have 2 significant figures out here for the volume. Which means this answer actually is going to be 7.2. That would be 4 with 2 significant figures. Don't ever forget your significant figures. Very important. Very important. Okay.